All right, so I'm going to do a little video on optimization, and that means I'm just going to go over quickly a review of everything that is entailed for this chapter. So optimization, also known as linear programming, what you need to know for the exam. So this is for Katerina who asked for it, and shortly Serena will be doing the video on mathematical expectation. Okay, so starting off, oh, there's my little shout out. I'm gonna erase that off the board. Right here, now getting rid of that. Okay, so we start off with a question that we'll do from beginning to end for optimization. So these are the steps that you need to know. First, you always need to identify your variables. So one is X and your Y variables. So identify variables. Sometimes in the problems, they already do it for you. So that's pretty easy. The second thing is there are a bunch of words that you need to convert into constraints. Sometimes that's done for you, and those will become inequalities. Then you're going to have to graph those and shade, and then you usually get some sort of shape called a polygon. And then the fourth thing is you have to find your corner points, which are also known as vertices, and that you're going to do by doing substitution or elimination or comparison, whatever makes you happy. And then the fifth thing is you're going to maximize or minimize by plugging in the corner points or some point into the function rule. So we're going to do one from beginning to end just so that you recap what needs to be done in function rule. Now that's the one, oops, sorry about that, function rule. Okay, so we're going to do one from beginning to end in the next screen. Okay, so I'm going to take the question from the exam booklet, which is Jersey Store, not Jersey Shore. It says that it's a sports store and they sell jerseys and baseball jerseys, hockey jerseys and baseball jerseys. So X would be hockey jerseys and Y would be baseball jerseys. So this is your X and Y. When you're doing your exam, you always have to identify its number of and number of baseball jerseys. So the first thing they said is that they have at most 400 jerseys. So when you read the at most, let me just write all the constraints here. Then they have at least 150 jerseys. And then they have a maximum of 200 jerseys, baseball jerseys. And then they said that there is at most 3 times as many hockey jerseys as baseball jerseys. All right, so the question is, they earn a profit, and what's the maximum profit they could earn if profit is $30 for hockey jerseys and $20 for baseball. All right, so the first thing you need to do is they ask what's the maximum profit. So you need to know that you have to graph this. That's the question. What's the maximum profit? So I'm going to just split the screen here, and we're going, whoops, not like that. I'm going to do it like that. Okay. So there we go. First, we're going to start off with writing down the constraints. I'm going to number each one. So this is 1, this is 2, this is 3, and this is 4. So for the first thing, these are constraints. You're going to write them as inequality. So at most, remember, the symbols are like this and like that. So this one is at most. This one is at least. And I always read from left to right when I'm writing down my my sentences. This is at least, this is at most, at least, and then this is a maximum of, and this is a minimum of. So in case you forget, make sure those are written down. So the first one, for number 1, it's going to be at most 400 jerseys. So together, X plus Y is going to be at most, so symbol like that, sorry, 400. And then this one's going to be at least X plus Y. Oh, actually, no, I forgot to write here. It's supposed to be hockey jerseys only. So if X is hockey, X is at least 150. And then a maximum of 200 baseball. So baseball is a maximum of 200. And then you've got the last one. Now the last one's really important. You see, it says 3 times as many hockey as baseball. So whatever is mentioned first, you put on the left. So hockey is X, and then baseball is Y, and then at most. So at most, but now there's that business of the 3. Since there's 3 times more hockey, which would be in front of the X, you have to compensate and put the 3 in front of the baseball, the one that's missing. And then that's it. Now we have to graph these. You can't get away with not graphing. You're going to have to learn to graph. So for those of you who forgot, quick step for graphing. You're going to make a table of values for each one. Some of you are really good at just memorizing what to do. But for the first one, it has to be, you could make up your own values, or you could just get the 2 X and Y intercepts. So for my first one, I'm going to just put when X is 0, so X plus Y equals 400. So when X is 0, Y is equal to 400. So 0, 400. When Y is 0, so X plus Y equals 400. Now X plus 0 is equal to 400. X is equal to 400. Now you could have done that in your head, but this is just a little recap of how to plug in a variable. This is when X equals 0, and this is, remember, when Y equals 0. So that's the first one. And now the second one is really easy because every time you have X equals 150, it's a vertical line. Remember that. So the line goes up and down like that. And then the third one's really easy as well because X is equal to 200. It's a horizontal line, so it goes like that. Now the fourth one is a little tricky because people put the 3 in the wrong place. So we're going to make a table of values. Here it's a direct. You cannot put 0 and 0 in diagonal because it's going to be 0 and 0 like this. There's no number by itself. So let's make up some values. So look, we have these big numbers like 400 and 100. So let's go with big numbers. If X, you could either isolate your X, so it looks like, your Y, so it looks like this. And I said if the denominator is a 3, you go with multiples of 3. So you can do 300. So if X is 300, so if X is equal to 300, then you would be 300 divided by 3 equals Y. So that's 100 is equal to Y. And that's just a little recap on how to do that. So your answer would be 100. You actually have enough points to graph this. So I'm going to go graph it on the next screen. So you're going to go. Usually with all these problems, there's the 2 non-negative constraints, remember, which means that everything's going to be in the first quadrant. Okay, so you're going to do little scales. So it doesn't have to be precise. So I'm going to go up by 100. So 100, 200, 300, 400, and 100, 200, 300, 400. So there's the first one, or maybe I'll go by 50s. Wait, 50, 100, 150, 200, 250, 300, 350, and 400. Okay, that's better. 100, 150, 200, 250, 300, 350, and 400. Okay, so my first line, I'm going to place it 0, 400. So I go to 0, 400, I put the point, and I put the other one 400, 0, and I make myself a line. Oops. Why is my dot moving? Okay. Having issues here. Okay, there's my first line. Then I'm going to go to my second equation, which is a vertical line at 150. So vertical line here, I go to the 150 and I make a line going up. And then I go to the 200, which is here, and I make a line going like this. I might not have drawn my graph nicely enough because of my separations, but we'll see in the end. And then I'm going to put my other line, which is, okay, so I'm going to just plot my points. So it's 0, 0, 100, no, 300 and 100. So it's like right here. And then I'm going to make that line. Something like that. Okay, so if I look at it, I have a few sections. I have 1, 2, 3, 4, 5, 6 sections, I believe. So I think my line is a little off. This section here shouldn't be here. It should have been lower. It's because my scale is drawn badly. I think, oh no, it should be there. It's fine. Okay, so I actually have quite a few sections. So let's look at it. I've got section 1, section 2, section 3, 4, 5, 6, 7, 8, 9. I have 9 sections. I have to figure out what part is shaded now. So if I look at the first line, it says, this one originally said that x plus y is at most. So at most was less than. So it's going to be, everything is going to be shaded in the bottom section. So I'm going to cross out what is not shaded. So not here, not here, not here, and not here. Then this line over here was this one here. X is at least 150. When it's at least 150, it's everything to the right of it. So 150 and more. So I'm not going to shade here, not here, and not here. So the sections so far are this little one, and this one here. So I have 3 sections that are left over. Then my other one was the 200, so it had to be y is less than 200. So this section is out, and I'm down to these 2 over here. Now my defining one is the last one, which was at most 3 times as many hockey jerseys as baseball. Now if you look at this, it looked like this. Very careful. Please read from the Y, or flip it over if you prefer. If you flip it over, it's 3y is bigger than x. That means you shade in this area and you cross out this. So you read from the Y. Now, let's say at the end, you're still not sure if this is the right section. Let's say you're not 100% sure. What you do is you take a test point in this region. Now, what do I mean by a test point? I mean you take literally a coordinate that's in here. So this is what I've defined as my new polygon. So let's say I'm not sure if this is one. What if I made a mistake? What if it was the one on the side? So I take a point. So I'm going to go like with 200 and 100. I'm going to just take a test point. And the one I'm going to take is 200, 100. Now this point, it means it must work in all 3 or 4 equations. So you're going to plug it back into each of these equations and see if it works. So let's look at the equations. I'll just move them over. So the first one was x plus y is at most 400. I'm going to plug in this point. Is 200 plus 100 less than 400? Question mark? Yes, it is. So far, so good. Second one, we're going to plug it into the x is bigger than 150. So we take the 200 because that's the x. 200, is that bigger than 150? Question mark? Yes, it is. Check. Third, we're going to take the other equation, which is y is less than or equal to 200. So we're going to plug in the y. Is 200 less than or equal to 200? Question mark? Yes, it is. So far, so good. So we're doing well. And then the last one is 3y is bigger than x. So we're going to plug in 3 times 100 is bigger than or equal to 200. So is 300 bigger than or equal to 200? Yes, it is. I kind of hesitated because I realized I made a mistake here. I should have plugged in the 100. It was 100 is less than or equal to 200, and the answer is still yes. Okay, so that was our test point, and because we said yes to every single equation by plugging in the point, then we know this is the good section. By the way, this is also the right way to do those multiple choice questions where they have a bunch of shaded lines and you have to figure out which one it is. You're going to plug in a test point. Okay, now that you've done the test points and you know for sure this is your good shaded area, you could go ahead and label your coordinates of your intersection points, A, B, C, and D. You can call them any letters you want. And we're going to now figure out what those numbers are. If you could read them off the graph, great, because it's pretty simple. But guaranteed, you're going to have to know how to do the intersection point using substitution, elimination, all of that. So you're going to get your corner points. From the graph, I know for sure what this and this and this are. I'm not too sure what this is. So I'm going to figure out C. So I'm going to go to another screen. But because I need the space, I'm going to just add a page over here. Okay, so for A, I'm pretty sure it's going to be 200, comma 150. Oh, the other way around, sorry. 150, comma 200. And for B, it's 200, 200. But if I wasn't sure, I would take the point of x plus y is equal to 400. And I would take the line y is equal to 200. And there it is. You just do the substitution and you plug this into y and you get x plus 200 is equal to 400. So x is equal to 200, which makes sense. And if I look at C, I can't really tell, but I know C uses x equals to 3y and x plus y equals 400. So I'm going to just plug in 3y into the position of x, and I'm going to go 3y plus y equals 400. That's 4y equals 400, y equals 100. So x is equal to 3 times 100, and x would be equal to 300. So my coordinates for C are 300, comma 100. And then for D, it looks pretty obvious, so it's 150 and 50. Now these corner points are important because they're asking us to maximize. And when you're asked to maximize, you need to look for the points that give you the highest value. It's not always the highest one. It could be B or it could be C. I'm going to look at what the function rule is. So according to my function rule, let me put that page over here. Okay, according to my function rule, where did I put that page? Okay, maybe not. There we go. Okay, so my function rule is the one that gives us the optimization table. So it was to be $30 for the hockey jersey plus $20 for the baseball jersey, and that's going to be my profit. So I take all of these points and I make that optimization table, You don't have to put all the points, but please make some sort of table so that I know what you're doing. So if you do make a mistake, I could at least realize what happened. So I'm going to plug in my A. I don't think A is going to be the point. I'm thinking it's either B or C. So I'll take the 200 and plug it in with the 30 plus 20 times 200. And then I'm going to do the 300 with the 30 plus the 100 with the 100. And I'm going to do the maximum. And the maximum is going to be, so if I calculate the 200 and the 200, I get 10,000. And if I do this one, I get 11,000. So this, and for you to get your marks, you need to indicate that this is your maximum. And there's your answer. So the maximum profit is $11,000. Okay, so that's pretty much a recap of that optimization problem from beginning to end. Now the things that you need to look for on an exam. Okay, let me just recap some of the questions you're going to see. We'll go to single page. All right, so things to look for in exam. They have questions where they already draw a polygon and they have like some sort of shape like this, and then they have a table of values on the side or an optimization table, and they have something like A, and they give you the maximum profit 84, B 84, and then they have C as I don't know, 105, or let's say it's the minimum profit. So minimum profit, and then they ask you how many solutions. How many solutions minimize. So every time you see this double answer, like 84, 84, there's 2 points that minimize or maximize. That means every single point on this line, and you have to be able to look for those intersection points between the squares. So how many solutions, you're going to have to count every single point on that line. Count coordinates that you could actually read off of that graph. Sometimes you can't see, so the answer might be more than 2. So that's one type of question. The next type of question that they often ask is they already have a polygon. They have problems, like a big problem they have to do from beginning to end. And then once you've drawn your shape, let's say you've drawn some kind of shape like this, then they say something like, oh, a new situation arises which minimizes whatever they're talking about, and you have to draw in a new constraint. And it might be something like, I don't know, now the maximum amount of hours is 30 hours. So you write something like this, if this represented hours and that represented type of hours, like, I don't know, working at the drugstore versus working at the garage. So, and then you draw this line, so you go to 0, 30, let's say 30, 0, wherever that might be, and you draw this very crooked line, which should not be crooked. But then you have to shade it, so then you have a new shape, and that new shape would have new coordinates, which you would plug into those function rules. Okay, and then the last type of question that they can ask, of course, or that you have to manipulate, is when they ask you to make sure that the points in the polygon are not decimals. So let's say that the corner point was a decimal and that wasn't a valid point. You'd have to look for the point closest to it. That would also give you a maximum or minimum, depending what the question was. So point closest to it in the polygon, making sure it's in the shaded region. Okay, so that's pretty much it, I think. And if there are any other questions, let me know, and I will answer them. All right, that's it. Now do I shut this off?